Good afternoon, everyone. I'm Ella, and on behalf of Solar Quarter South Asia and First View Group, it's my honor to welcome you all to today's masterclass webinar, Leading into Infinity Myanmar, LONGi, HIMO 9, and BC product launch. Before we begin, I would like to extend our heartfelt gratitude to LONGi for making this event possible. Their continuous commitment to driving innovation and advancing sustainable energy solutions is truly inspiring. Now let's take a moment to watch a brief video from LONGi. I request my team to play the video now.
When sunshine and technology come together, it will bring limitless green energy to the world and open up the path toward net zero ecosystems. LONGi pioneers energy transitions in the terawatt era with solar power and leads the world toward the goals of carbon peaking and carbon neutrality. It implements the green power plus green hydrogen strategy for net zero global development and focuses on technology-driven energy transitions in the bid to create a sustainable future. With foresight, LONGi works to create an enabling industry ecosystem. Monocrystalline silicon wafers, cells and modules, utility solar PV power systems and solutions, C&I and household distributed photovoltaic solutions, and hydrogen equipment in 5 business sections set up by LONGi. With perseverance, LONGi specializes in monocrystalline silicon wafers. LONGi focuses on R&D production and sales of monocrystalline silicon ingots and wafers, and leads the industry in diamond wire slicing technology. It breaks new ground in technology and manufacturing through digital transformation. Its full line of silicon wafers has passed the French Carbon Footprint ECS certification. With wisdom, LONGi sets new records in conversion efficiency of cells and modules. LONGi has shattered multiple world records in cell conversion efficiency. Its self-developed N-type HJT solar cell breaks a 5-year record, leading China's solar PV industry to take the top spot in the world. LONGi's solar modules feature high reliability, efficiency, yield, and other strengths, earning trust from global customers. LONGi sets the lifestyle quality standard to improve customer experience, ensuring product reliability and long-term value. LONGi has stayed number 1 PV module supplier worldwide by shipment volume. Through innovation, LONGi provides ground PV system solutions driven by application and innovation of PV plus approaches, complementary energies, integrated power supply, grid, load and storage, decarbonization of high carbon consumers, ecological restoration, and rural revitalization. LONGi is committed to developing highly reliable solar power stations in entire lifetime to support the development of new power systems, empower the transition toward low and zero carbon, and provide green wisdom and green power for attaining the goal of carbon neutrality. Through continuous exploration, LONGi provides C&I and household distributed photovoltaic solutions. LONGi has operations in various countries and regions and provides highly efficient PV modules for C&I and household customers. It empowers partners by meeting their needs in specific application scenarios. It provides scenario-based innovative solutions for household solar plus storage system and BIPV for cement rooftop, flexible rooftop, and metal rooftop. The LONGi sunflower platform provides a one-stop rooftop PV solution for households, the first of its kind in the industry. LONGi leads the industry in creating a sustainable distributed solar PV system. With a grand vision, LONGi shapes a new hydrogen industry ecosystem. LONGi Hydrogen aims to be a world-leading green hydrogen equipment and solution provider by developing an innovative eco-chain for hydrogen technology and providing integrated solutions for green power plus green hydrogen. LONGi Hydrogen accelerates energy transitions. The planned capacity for 2025 is 5 gigawatt to 10 gigawatt. In good faith, LONGi sets the way forward. LONGi adheres to its right sustainable development concept, implements the solar for solar mode, and builds net zero factories to support climate action. It upholds the win-win for all long-termism and strives to promote harmony between man and nature. LONGi makes the best of solar power with technology and works toward a net zero future together with global customers and partners.
LONGi.
Thank you for that, team. We will now be screening the LONGi HIMO product video.
We aspire to transcend limits, much like the Fibonacci sequence unfolds, unfurling possibilities step by step. Now, the dream is becoming reality. Meet HIMO 9, a game changer for global power station asset owners. It's not just the best solution, it could be the ultimate one. Introducing the next generation HPPC cells, ultra high efficiency, utilizing brand new silicon wafer tie array. HIMO 9 delivers exceptional performance, achieves remarkable efficiency and superior power. Optimal degradation performance ensures consistent high power generation for a lifetime. Ultra-low temperature coefficient. HIMO 9 never compromises with high temperature and power generation. Uneven radiation will no longer be a problem. And current non-uniformity risks are effectively mitigated. We anticipate every risk in a world of uncertainty. Surpassing industry standards, assure quality with digital manufacturing and AI-driven inspections, guaranteeing peak performance. Ultimate, efficient, durable, safe, quality, reliable, altogether, leading to infinite value. Now, we have the final answer. HIMO 9, the beginning of the next ultimate.
Thank you, LONGi, for that insightful video about the company's mission, achievements, and the incredible HIMO 9 product. Now, let's dive into today's program and explore the latest advancements in solar technology. Today, we are privileged to explore cutting edge advancements in solar technology with our distinguished speakers. To start, we are honored to have Dr. Shah, who will share his expert insights on leading technology. Dr. Shah, the stage is yours.
Good afternoon, everyone. I'm excited to join you today to discuss the technology behind our new product. So in Longi, we believe BC technology is the future of solar. In this presentation, I hope um, we can find why and how Longi will make this come true. So in the first section, I'm going to briefly introduce the PV technology trend. So here I borrow from the Gartner hype cycle chart to illustrate how solar PV technology evolves. So there are different materials. There are for solar cell. We have thin films, we have silicon PV, and the silicon PV is dominating the market by over 95% market share. And in thin films, there are new technologies that is coming up, like perovskite. As the silicon technology evolves, we have gone through three major stages. We started from early this century. We started from the aluminum back surface field solar cells. And then we evolve into PERC technology. And starting from last year, we see TOPCon is taking up the market. So we see BC technology as the ultimate evolution of silicon PV technology. So there is a simple principle for evolving to BC technology based on a very simple requirement for a solar cell, which means we want more light in to the solar cell and more power out from the solar cell. By comparison, side-by-side comparison of a PERC or TOPCon or HJT solar cell to our BC solar cell, we can see the clear difference at the front side. On the PERC, TOPCon or HJT solar cells, we can see the front grid lines. By developing BC technology based on this structure, we remove the front grid lines and we do patterning on the backside alternatively, so we can basically receive more sunlight. That's the basic principle for high efficiency based on BC structure. So in the past 3 to 4 years in LONGi, we have developed basically all kinds of silicon PV technologies. But we reached our highest efficiency based on BC structure. We see from this chart that there are only two BC solar cells have demonstrated efficiency higher than 27%. So from the R&D side, we see that only BC technology can reach the theoretical limit for silicon PV solar cells. And by far, only LONGi's BC cells is entering the exclusive 27% club. So step into the production stage. We see 4 different major silicon solar cell in production. Early this about decades ago, we started from below 20% solar cells based on the BSF technology. Then we escalate the cell technology to PERC. The efficiency is below 25%. And now we have TOPCon heterojunction solar cells with efficiency above 25%. But still, over the past 20 years, from this green line, we see BC solar cells always show highest efficiency among all silicon PV technologies. But why is not in cells in the solar modules From this chart, we see that starting from the last 2 years, the BC solar modules efficiency is ramping up very quickly. That's because companies like LONGi solved the core challenge for BC solar module fabrication, which is the complicated process. So in summary, silicon PV is evolving to its ultimate efficiency with BC technology, and BC technology demonstrates highest cell efficiency in lab and mass production. BC technology demonstrates highest module efficiency. So coming up next in the second section, we're going to introduce why LONGi is leading BC adoption. So in this slide, the left chart, we have seen this in the very first slide. That shows the evolution of silicon PV cell technology from diffused contact, including BSF and PERC technologies, to passivated contact, including TOPCon and HJT solar cells. And now we are introducing back contact solar cells. The cell efficiency is improving continually from 20% to 25% to 26% and to over 27% based on BC structure. I will see that BSF and PERC is phasing out. Actually, BSF technology has phased out of the market, and PERC is phasing out. The TOPCon is taking up the market. That shows the recorded cell efficiency. So behind the cell technology evolution, actually the silicon wafers is evolving as well. So we see from the major transfer from P-type silicon to N-type silicon, when the cell technology is transferring from diffused contact to passivated contact technology. From passivated contact to back contact technology, LONGi has developed a Terry wafer, which is especially helpful for the BC solar cell manufacturing. We see different BC solar cell technology here on this table. So in LONGi, we developed HPBC first generation, HPBC second generation, and we also developed the HPC solar cells. And the efficiency is improving as well. And in every category of different BC solar cell technologies, LONGi is leading in cell efficiency. And also LONGi is leading in cell production, mass production as well. So from very high efficient solar cells to solar modules, it takes a lot of efforts, basically because BC solar cells are more complicated to fabricate. There are more steps than PERC or TOPCon technologies. So that's why in the past, the PV industry rarely seen successful BC manufacturing. But our unparalleled R&D capabilities position us at the forefront for innovation in the solar industry to leading the adoption of BC technology. So here in LONGi, we have more than 1,000 R&D team staff, and we filed more than 500 patents. And we have over 100 granted patents. So one most core innovation in BC solar cell development is we developed the insulation materials. Our self-developed insulation materials break efficiency barriers, enabling higher cell performance, which brings us more than 0.2% efficiency gain. So we also streamlined the process of BC solar cell fabrication. So traditionally, BC solar cell takes a common ordinary BC solar cell takes more than 20 steps to fabricate. That is complicated process simply because we are placing both front and back contact on the same side. So we have a lot work to do with patterning processes. Of course, we use lasers, and we develop the insulation processes and the materials. So based on the innovations, we have solved the core mass production issues of BC, and we have achieved mass production feasibility. So now our LONGi's BC solar cell can be fabricated within 15 steps. That's a major leap. And from module to product, we have a roadmap to continuously improving our module efficiency from like 650 watts to above 680 watts based on our BC platform. So in LONGi, we have a diverse silicon solar panel silicon products. So we are the leading manufacturer for PERC solar cells, and we have developed HPDC technology as well. And in the past 3 to 4 years, LONGi established a dedicated BC platform to boost the development of BC solar cell development and product development. And we have three products, which is HPBC, HPBC2, and HPC. And we are also developing tandem solar cells for the coming 5 to 10 years time. So by the end of 2025, LONGi's BC production capacity will scale up to 70 gigawatts. So in this slide, I'd like to introduce why LONGi is leading the major silicon PV technology evolution in the past, and from the introduction of BC technology in the coming 7 years and beyond. So these two figures on the left, these two figures are from a publication from the Journal of Joe, which is a high indexed journal. And this research is conducted by researchers from UNSW, University of New South Wales. So we see that from this figure, the black line shows how monocrystalline silicon is taking up the market, and all the other lines are predictions. We see that starting from around 2012, LONGi has set the target to develop monocrystalline silicon wafers, and we make monocrystalline silicon wafer the mainstream silicon wafers in the PV industry 7 years ahead, about 100% of the market, 7 years ahead of the industry prediction. So in the right figure, that's prediction for BC technologies. So you can see that 10 years ago, the industry expected the BC technology is taking up like to about 20% of the market share by this year, but it's not happening. Why? Because like I talked before, the complicated production process. But by this year, LONGi has solved this problem, and we look forward to the BC technology taking up the market share very rapidly in the coming 3 to 5 years. So in summary, so why LONGi is leading VC adoption? So firstly, LONGi excels in R&D, producing state-of-the-art BC solar cells. LONGi has established a dedicated BC platform to accelerate BC commercialization. And LONGi has pioneered in the transition to monocrystalline silicon wafers and is set to lead the shift to BC cell technology. So in the last section, I'd like to talk about several aspects, maybe 3 major advantages of our BC product. So from the previous videos, you see BC products have diverse applications. Its value can be amplified across diverse market applications. So again, there's a very simple requirement for solar products. So we expect it can power longer and power more. So here I'm using a water bucket analogy to explain why BC product, a BC module can power longer. So a solar cell is like a water bucket with some pinholes. Basically, these are energy loss channels. So energy flows in, but power leaks through the pinholes. So with highly efficient BC cells, we are using high quality wafers, and also we are using superior surface passivation. So basically, our BC cell efficiency is higher because of fewer power loss channels. So the right 2 figures compares a less efficient cell to an efficient BC cell. So under low light illumination conditions, a BC solar cell, because of less power loss channels, can retain higher voltage than a less efficient cell. So maybe here, a solar product or the system starts working based on a threshold voltage, and a BC solar cell can start working earlier and stop working later due to the higher voltage and low light conditions. Also, BC products can power more based on its better temperature management. So first one is better temperature coefficient. So the solar modules, every solar module we see, its power output will drop at increasing temperature. So this figure shows different how much the solar module its voltage drops. The main drop is from voltage. How much voltage drop from different technologies. As you can see that it's closely correlated to its initial voltage. And from BSF to PERC to TOPCon to our HBBC solar cells, we see an increasing initial voltage. And so we basically, our solar cells and the solar modules show a lower voltage drop at the same elevated temperature. So here's an analogy for your easy understanding again. So basically, a HIMO 9 solar module is not has a better temperature coefficient, is not sweating at hot weathers. Another advantage is hot spot management for our BC solar modules. So solar cells are connected in strings in the solar module. So in traditional like a TOPCon solar modules, when a solar cell is shaded, so it's not working basically without sunlight. So this solar string, this whole string will be bypassed by a bypass diode. So solar power generated from these 1, 2, 3, 6 solar cells will be totally wasted. In comparison, in our HAMO9 solar module, when this cell, the same cell in the same position is shaded, the HVBC cell has a tunneling diode in the cell. So the current still tunnels through this cell. So we only have power loss from this single cell only. So this is possible because we are placing both N and P contacts on the same side. That gives us a chance to making a tunneling diode in our solar cell. So in summary, BC products see versatile applications, and it works in extended power generation. BC product captures energy early in the morning and late in the afternoon, ensuring longer daily power production. And BC superior temperature management makes the BC product maintains optimal performance even in high temperature conditions, generating more power. That's my discussion of our new product from the technological perspective. So I'm happy to take any questions later.
Thank you so much, Dr. Shah, for enlightening presentation and for sharing your deep expertise with us. Now, before we continue, we'd like to gather some quick information and to get to know our audience. So I'll be screening some poll questions here. So this is our first poll. Please specify what is your role in the industry. Are you an end user, IPP, EPC, distributor, or a consultant? So the poll will stay open. I'm just going to hide it here from screen, but it will still be visible here in the polls section, which is below the Q&A box. And our viewers and audience can keep on taking the poll till the end of the webinar. Our second poll is regarding which type of module mount do you use? So I'll just present it here on screen. So we have the options available are ground, residential rooftop, CNI rooftop, floating, or any others. Again, the poll will stay open till the end of the webinar in the polls section, and I request the audience to kindly fill in their votes before the end of the webinar today. I'll just hide it here from screen, but still be available in the polls section. Moving ahead, we have Mr. Yu Hao Sun, who will introduce exciting product launch of the LONGi HIMO 9 and BC. So Mr. Yu Hao will guide us through the transformative innovations that are shaping the future of solar energy solutions. Without further ado, I now invite Mr. Yu Hao to begin his presentation. Over to you, sir.
So, hello, could you see my screen now?
Yes, sir.
Okay, no problem. So I will get started. So, hello everyone. My name is Yu Hao Sun. So thanks for joining today's meeting. And today's my content consists of 3 parts. So the first part is a LONGi company introduction, and the second part is a HIMO 9 product introduction. And the last part, I will introduce our LONGi GSE design software. So LONGi is a technology company, and we founded in 2000. So we're focusing on solar energy, and we aim to leading the world's transition to green energy. And we start from produce ingot, and in the past 20 years, we were constantly expanding our industry chain. So we have developed our business into 5 parts. The first is wafers, then the second is cells and modules, and the third one is the distributed PV solutions, and the next one is the utility or ground-mounted solutions. And the last one is the hydrogen energy system to support the global zero driving. So in order to get closer to our customers and provide our services, we have established our branches more than 50 countries and regions to build our sales network. So in Asia, we had our Asia Pacific headquarters in Kuala Lumpur and also 3 manufacturing bases there. And according to our annual report, so LONGi's operating revenue in 2023 achieved 130 billion in RMB, and which increased by nearly 76 times than 2012. And the module shipment we reached is 67.5 gigawatt, and wafer shipment 125 gigawatt. And this means by the end of 2023, around 27% of world's installed capacity of PV wafers are manufactured by LONGi, and LONGi avoid 800 million tons of carbon dioxide emission. So for our products, so in the past 24 years, we achieved mass production in many different battery technologies. As you can see from the chart, from the number 1 to number 4 are already mass produced yet and applied in our product. So for the first one is the PERC cell structure, and we applied in our HAMO 5. And second one is HPDC cell structure applied in HAMO 7. Then HPBC in HAMO X6. And the number 4 is HPBC 2.0, the new generation one, applied in our new coming panels, HAMO 9. And the product in 5th and 6th row is HBC and tandem cell structure, and they are still in R&D stage. And HBC plans to launch by the end of next year, and tandem in 2030. So then let's get into the product part, and we name this product HAMO 9. And HAMO 9 have 3 main advantages. The first one is the best efficiency of HAMO 9, and the second one is the best value of HAMO 9 can bring to our end users. And the last one is the best reliability of this HAMO 9 product. So in this best efficiency part, I will go through the features of cell efficiency, like temperature coefficient and so on. So for HAMO 9, we use the LONGi latest cell technology, HPBC 2.0. And this is new technology makes HAMO 9 have 24.43% cell efficiency and 660 power output. So compared with TOPCon panels, the efficiency of TOPCon panels is only 23.32% now. So which means for one piece of panel, the power of HAMO 9 is 30 watts higher than the same size TOPCon panels. So assume panels have 4 working hours in one day. So HAMO 9 can generate 0.12 kilowatt hour more electricity than TOPCon for every single panels. So which means one panel HAMO 9 can generate 0.12 kilowatt hour electricity. So choosing HAMO 9 equal to choosing 5% more electricity for your project. And for temperature effect, so all the PV module have these features. So as the increase in temperature, the performance of the products will drop. And the magnitude of dropping, we call it temperature coefficient. So the logic is similar to the mobile phone. So if you use the mobile phone in hot weathers, so the phone will getting hotter and hotter, and the battery life will decrease. So back to the product HAMO 9. So as the working temperature increased 1 degree, the performance of HAMO 9 will drop 0.26%. And this number, this dropping for TOPCon is 0.29%, which means when temperature increase 1 degree C, the TOPCon will lose 0.2 watt more power compared with HAMO9. So for one pieces of panel, which working temperature is, for example, 45 degrees C, so HAMO9 will save 5 watt power caused by temperature rise. So in some extreme situations, for example, like 85 degrees C working temperature, HAMO9 can save 14 watt power caused by the temperature effect. So for the degradation, still I want to say the example of mobile phone I just mentioned. So you can check the battery health condition. So you may find after your phone used 1 or 2 years, the battery health number may drop, for example, like 10% maybe. So PV panels are completely same. The power will drop during the whole life duty time of the PV panels. So because we use the double PoE and better terry wafer into our HAMO9, and they make HAMO9 have better anti-aging performance. So for the linear degradation, our HAMO9 number is 0.35% performance drop per year. And this is 0.05% less than TOPCon modules. And besides the direct degradation, like linear degradation, so in one system, if different power panels connect with each other, then there is a mismatch loss will happen. So more power difference connect to each other will make more mismatch loss. So in terms of degradation, we can say more degradation will cause more mismatch. So HAMO9 with lower linear degradation also lead lower mismatch loss caused by degradation due to this mechanism. So by conclusion, for the degradation, so in HAMO9 have 0.05% less linear degradation will save 1.51% more power overall than TOPCon modules. So equipped with new generation technology, HPBC 2.0, HAMO9 has better low irradiance performance as well. So as we all know, the power of the panels depends on the weather. So like in another word, how strong the solar today. So better sunlight will result in more electricity produced by the panels. So if the sunlight not good today, how about the performance between different panels? And here is a video to show the test we did. So in this test, we installed HAMO9 and TOPCon modules to drive the water pump, and we varied the light to see which water bar is higher. So as we reducing the light, you can see the water bar from HAMO9 drop slower than TOPCon modules. And we increasing the light, the water bar increasing earlier and faster for the HAMO9 modules than TOPCon modules. Yeah. So this test mimics the sunrise and sundown of one day. So as the result, HAMO9 has longer working time compared with TOPCon modules. And the HAMO9 can generate 0.1 to 0.4% more power, depends on the different irradiance in one day. So last one affects the efficiency is the shadow effect. And this is always happen in the real project. For example, like bird drops or leaves, and the shadow caused by the dust. So when there is a shadow on the cell will become resistant to generate heat. And once the heat increases a lot, then there is a risk of fire. So in order to eliminate the risks, PV manufacturer add junction boxes with bypass valves on the panels at the backside. So from the right-hand side is a traditional design. So once there is a shadow, for example, like bird drops, the junction box will bypass two rows, and the two rows will not working. So there is no heat generated by these two rows to eliminate the fire risks. But for our new product, HEMO9, we optimize the design with our BC cells. So when shadow happened, HEMO9 can only bypass the cells covered by the shadows, and the rest cells can still generate power. So this makes the power losses due to the partial shadow can be reduced by 34% than top-hole modules. So next page, there is a video to show the comparison test we did for this shadow effect. So in this test, still we installed HEMO9 and top-hole modules to drive the water pump, and we varied the number of covered cells to mimic the shadow effect. So when we covered all the cells in the middle row, you can see the performance difference. Yeah, like now, when we covered all the cells in the middle row, by observing the water bar, you can see there is almost no power generated by top-hole modules, but for HEMO9, it can still generate electricity to drive the water pump. For the best value, for this section, I will introduce the simulation and the experiment results we did. And also, we calculate the BOS for different projects as well. So for the first section, the efficiency section, we just go through the content of high efficient of HEMO9 and compare with top-hole modules. And this chart is a summary which concludes the advantages compared with the top-hole modules. So because of all these advantages marked in red, so in the real project, if you choose HEMO9, install same quantity, same pieces. So choosing HEMO9 means choosing 6.5% to 8% more power, more electricity. So we also did a real set test. So we installed HEMO9 and top-hole modules in China testing area, and we collect 1 month data and analyze the performance difference between HEMO9 and the installed top-hole modules. So for every pieces of panel we found, the power generation is 6% more for HEMO9 compared with top-hole modules. And this test period is relatively short because we just collect the information, we just collect the data in 1 month. So it is unable to reflect the impact of the degradation on the panel performance. So for long-term panel performance, the power generation of HEMO9 will be better due to the 0.35% better linear degradation. So we also calculate the BOS globally using HEMO9 and top-hole modules. So we use the electricity calculate the PVCs and using the layout of the real project we did before as the input into the financial model. And as the result, you can see the BOS saving is different for different area, and the gap is around 2 cents USD between HEMO9 and top-hole modules. So by conclusion, as a result, HEMO9 can save around 2 cents BOS than top-hole modules. Then the last part is the reliability of the HEMO9 product. So firstly is the LONGi warranty. So for HEMO9 standard warranty, we provide 12 years for the raw materials quality and 30 years for linear degradations. So once you observe any defects, you can directly contact with LONGi and send your problems. So after the analysis of our after-sales team, if there is not caused by users, LONGi will pay for the claims. And besides, we also did the DH, UV, TC test under IEC standard to test the durability of our HEMO9 in aging test. So from the bar chart, you can see compared with the top-down modules, HAMO9 has better performance in all these three aspects. And for the customer claims or after sales, according to my personal experience, around 40 to 50% of problems I received are hotspot issues from my users. So after the analysis from our after sales team, about 95% are caused by shadow, sometimes maybe bird drops, sometimes maybe dust. And if this cannot be cleaned for a long time, and hotspot will happen. Oh, sorry. So because of the anti-shading feature of HAMO9, the highest temperature of HAMO9 reduced a lot, and this reduced the risks of hotspot. Then let's see the test we did in our lab. So in this test, we choose HAMO9 and top-on and covered one cell. Then we put them into the testing boxes and make sure the irradiance are same in this test for two different modules. So after 1 hour, we get the samples out, and then we use the IR tester to test the temperature. So as a result, the highest temperature for HAMO9 is 52 degrees C, less than top-on modules, which could dramatically reduce the failure rate caused by the hotspot effect. So for mechanical strength of cell, when we batch module, and you know there is a long way from factory to our customers' hands to transport the product. So normally truck transport, then ship transport. And there are some micro crack of cells are caused by the transportation process. So this failure is not always, but it is possible, and we do receive some feedback from our users. So in order to reduce this micro crack, reduce these issues, we use the thicker wafer into our panels. And we did a finite element analysis, and we simulate the maximum stress acting on HAMO9 and top-on wafers. So under the input is 2,400 Pascal load. The maximum stress of HAMO9 wafer is 1.3 megapascal less than top-on wafers. So which means the thicker wafer has a stronger strength. And apart from the wafer thickness, we also optimize the welding method to reduce this micro crack failure caused by the transportation. And traditionally, a Z-shaped welding method are used in the manufacturing process. You can see from the second pictures. So between the two wafers, I use a red line to show the welding. So you can see the grid line start from the surface of one wafer and pass to the backside of another one. So at the edges of the wafer, there is a extra load compared with HAMO9, compared with the HAMO9 I-shaped welding method. So for HAMO9, we use the I-shaped welding method, and all the grid line is in one side, is in backside. So there is no extra load acting at the edges. And by testing, the load is 50% less than the top-on traditional Z-shaped welding method to reduce the micro crack. So this is the last part. So apart from the new product, apart from the advantages of the HAMO9, so we also provide services to help our customers to do the PV plant design and plant management and operation. So in this part, I will give you an introduction about LONGi GSE software. So first is an overview. So in the past 10 to 15 years, the installation capacity of panels increased a lot, And this caused a huge challenge in PV plant management and operation. So PV plant has such features compared with nuclear or thermal power plant. PV power plants have large area and normally they're located in different areas. Sometimes these areas is very far from the city, sometimes in mountains or desert. So it is hard or it is costly to do the management and maintenance for this remote PV plant. So compare with wind power plant, PV power plant consists of many components. Like for example, in the system panels, there is panels in the system, inverters in the system, and cables in the system. So when the power generation is not expected, so besides quality issues, the design, the installation, the environmental changes of the site, and there are a lot of possible reasons will make the system have this low performance. And this is very hard to find the key problem directly from our by our users. So in pre-sales communication with our clients, some are EPCs, some are IPPs, we identified some common pain points. So from the design stage, customers want to invest the PV plant, but they do not know how to do the design and how much power could be generated by the PV plant. And they don't know the profit to support them to make the decision to do the investment. And for some customers already hold many plants, there isn't a platform for them to monitor all the plants easily. So if they found the performance not reach the expected value, they cannot find the problem directly, and the fixing time will cost few days. So the profit will losing during these days. So in order to help our customer, we design these GSE softwares. So GSE solution is designed to enable the lifecycle management of the PV plants for our users. And this software is suitable for all scenarios, mountains or offshore. So the colored ones are already released and the gray ones are still under development. So in the following introduction, I will focus on the colored ones, including 3 softwares. So the overall target of GSE solution is to help our customers to save money in all stages. And here is a diagram of cost breakdown. So firstly, GSE Pioneer is a fast design tool, can reduce the labor cost during the PV development stage. And also by the smart design algorithm of this Pioneer software, a best PV layout and design could be given by this software to get the highest profit for our users. So secondly is the GSE Protector is a monitoring O&M platform, and this can help customers to reduce the labor cost during the management stage. So it's a remote monitoring system will be provided to reduce the operation cost. So finally is the GSE Challenger is a performance analysis system, which can help customers to identify the performance gap between real and expected value. And O&M advices will be given to guide you to solve the problems to keep the healthy of your PV plant. So next, I will introduce some details of GSE Pioneer. GSE Pioneer provides a SaaS solution. It is a one-stop design software for you. You can use in the web page. So because of the smart design algorithm, the resources evaluation and design process will be reduced from 7 days to 15 minutes. And this smart design function could be used in different scenarios. for example, like flat land, mountains, and floating solar design. And for the function breakdown, so in the PV design stage, you can run a quick design process with default parameter like panel tilt angle, pitches, and so on. And the algorithm will give a suggested parameter for the smart design function. So for creating the boundary line for your land property, CAD or KMZ files are allowed to be uploaded into the software. And you do not need to input the weather information as well, like solar irradiance, because these are already set in the software. So if you have some special design standard, you can modify the parameter as well. So all the data could be customized, like road design, like equipment choosing, and structure design. So after you finished all the input by the software will calculate the BOQ and LCOE directly for you. Then you can use the data to make a comparison between different panels, different inverters, or different design. And for the result accuracy of this GSE software, because now most of people doing the PV analysis, they are using the PVSys software now. So in other words, PVSys result is a reliable result now. So we compare the result from our GSE with PVSys and certified by TUV, the third party. And the third party did the test for different locations and different module types and the different mounting structures. And the result shows the difference between GSE and PVSys result is less than 1%. So you can directly use the result from the GSE software. So next one is the protector to consider how to build an efficient O&M system. So GSE protector is a digitalized platform to do the PV plant O&M, and the drone IR detection is allowed to be managed by this platform. And the data showing the platform can support the manager to make the daily management plan from the HQ, even the site is very remote from the HQ. So Protector is also a smart professor who good at modules and PV systems to find the problems in the power station for the PV power station manager. So finally is the challenger. So after we get the data from the protector, challenger will give advices or solutions to the manager. So according to the experience, only monitoring and doing the regular maintenance, for example, regular cleaning or regular inspection, is not enough to achieve the maximum production. So then we realize it is important to do the advanced O&M, and this O&M need to be based on the real size data, and according to this data to do the solution to make the plan. So doing the different O&M based on the performance analysis, we realize 3 challenges. The first one is how to evaluate. The second one is how to analyze this data. And the last one is how to improve, how to give the advices. So that's why we developed this GSE Challenger. So it is an expert who can help you to maximum the performance of your PV plant. So the whole analysis process is automated and processed daily. So the analysis is always based on the last day's data. So you do not need to worry about whether the data is out of date. And for the different roles, Challenger could give different guidelines, different solutions. So for manager, there is performance overview. including ideal generation and loss diagram. And for analysis, there is inverter efficiency and string health analysis tool for them to watch, to see. And for the O&M workers, O&M advices will be provided to the local workers. And lastly, for the advices, Challenger could provide loss break diagram in 10 categories with the solutions to tell you how to fix the losses. So the categories such as strain loss heat map, inverter efficiency ranking, and data quality statistics. So generally speaking, GSE Challenger can set a goal and provide the guidance to achieve the goal. Yeah, so that's the end of today's meeting, and hope you enjoy the content of LONGi HAMO9 and GSE software. So thanks for everyone.
Thank you so much, sir. That brings us to the end of our question answer session as well. Thank you all for your active participation and insightful questions. I would like to once again thank Mr. Yu Hao and Dr. Zhe for their illuminating presentations and the informative presentations that they showcased today. Before we close, I'd like to once again thank LONGi for their unwavering support and dedication in organizing this event. And to our valued participants, we appreciate you joining us today to explore the forefront of solar technology. So stay tuned for more such engaging sessions, and thank you for being a part of this insightful webinar. Have a wonderful day ahead. Thank you all.